hit the record here. So we're going to do some notes on compound inequalities, which is really not that different from what we did yesterday. It's just going to add one extra thing, which is we're going to do problems that have two inequalities in them, but we do them the same way that we did yesterday, meaning that we figure out where the boundary point is, and then we got to figure out where the true values lie on the number line. And it's called a compound inequality because we are going to be looking at two of them at the same time. And then after we finish the notes today, you guys will have a delta math. Okay. So compound inequalities. Okay. Compound inequalities is when two simple inequalities are combined into one statement. We use the words and or the word or, and we create a compound inequality. Okay. So we end up with two inequalities connected by either the word and or the word or. So down here, it says you can graph the solutions of a compound inequality involving and. So this is all about and right here. The way you do that is you graph both of them. And means that they both need to be true. So we find the overlap. For example, if I were to graph x is less than 10, it's all of these numbers here. And then if I were to graph x is greater than 0, that's all of these numbers here. These numbers here in the middle are the only numbers that are highlighted for both of them. So that's our final solution. So in other words, we look at the two that we have and we find out where they overlap. So we're looking for the intersection or the overlap of the two solutions. So some people do this like on one number line and they like highlight, for example, less than 10, and then they highlight greater than 0 right here, and they go, oh yeah, the overlap is right there, and then here is my solution down here. So it's basically the numbers between 0 and 10, okay? So an and means that we want to figure out where the two solutions overlap, okay? So we want to figure out the numbers that are less than 10, and at the same time, they're greater than 0. So it's these. These are the only numbers that are both less than 10 and greater than 0. And we talked that you can write it like this. This is a fancy way of writing the and statement, and it's the same as saying between. So 0 is less than x, which is less than 10, is the same thing as saying x is greater than 0 and x is less than 10, or x is between 0 and 10. Okay, because that's what we're saying here. X is all the numbers between 0 and 10. So the way that we would do this, for example, A right here, if we want to solve this compound inequality, has the word and, we just do these each separately. So my first one says x plus 1 is greater than -5. So if I treat this as an equation, I can subtract 1 from both sides. So subtract 1, I get -6. Now I can test a point to see whether my arrow is going to go to the left or to the right. But let's go back to the other way. I just solved, okay? How did I solve? I subtracted 1. That's all I did. Did I multiply or divide by a negative? Nope, there's no multiplying or dividing at all when you solve this. So guess what? My sign's not going to change. So this is going to be x is greater than -6. We do not flip the sign because we literally did no multiplication or division. You could argue at the end we divided by 1 because you always divide by whatever's in front of the x, but it doesn't change anything. So bottom line is I did not multiply or divide by a negative. Same thing here. If I subtract 1 from both sides, I did not multiply or divide by a positive or a negative. So since I didn't do any multiplication, my symbol is going to stay the same. So I am looking, we have this nice little word and in the middle. We are looking on this number line for numbers that are greater than -6 and less than 1. So let's see, I'll put -6 right here, -5, -4, -3, -2, -1, 0, 1 would be over here. You can put them wherever you want, doesn't matter. But I'm just spacing them out correctly. But if those little tick marks weren't there, you just put -6 on the left and +1 on the right, because that's where they are. And we are looking for all the numbers that are greater than -6. So I'm going to highlight greater than -6 is those. We're going to look for numbers that are less than 1. I'm going to highlight with a different color. Those are the ones that are less than 1. Do you guys see the overlap? This section in the middle here just got highlighted twice. These are the points that are both. They're greater than -6, and at the same time, these points in the middle are less than 1. So those are really the points that I want to look at. So I have a boundary point at -6. I have a boundary point at 1, and I'm looking only at the points in between. Okay, no equals, no equals, so I do not fill in the circles. You fill in the circles whenever there's an equal to in one or both of your inequalities. Okay, so that is the answer. However, most people, when it's an and, like to write it like this, that -6 is less than all the x's, which is less than 1. So with an and, we can combine it into one big inequality statement using two inequality symbols. So -6, less than means to the left of, is to the left of all the x's, and all the x's are to the left of 1. That's what those less thans mean. So we're just reading from left to right. Okay, so the smaller number first, then a less than, and then your variable, and then another less than, and then your bigger number. So you're just reading from the less than all the way to the greater than number on the other side. Okay, part B, same thing. I'm going to solve this, and we're going to solve that. So 3x minus 1 is greater than 8. This is a two-step problem. So if you want to change it to an equation, if that's easier for you, do that. Add 1 to both sides. So 3x would equal 1. And here's the big question. We're going to divide. And why do I write 1 when I'm adding 1 to 8? I should have written a 9. So sorry. Add 1, you get 9. Now we're going to divide. Here's the big thing, though. When we divide, we are dividing by a positive. When you divide by a positive, the symbol in the problem stays the same, greater than. So now I know that I'm going to keep my greater than sign. So my first inequality solves and says we're looking for numbers that are greater than 3. And let's figure out the other one. So 3x minus 1 equals 11. Add 12 or add 1 to both sides to get 12. Same thing. I divide by 3. When you divide by positive 3, your symbol is going to stay the same. And again, if you don't like the whole, did I divide by a positive, did I divide by a negative, go back to testing a point. Test a point. We can see that this is going to be 4. So test a point. Test a point that's less than 4 and see whether it's true. Are we going to keep the less than or equal to? Or are we going to flip it? So test a point and see. But here, 4, we divided by a positive. I'm going to keep that sign the same. So I'm going to leave this the same. So I get x. I get 4, because 12 divided by 3 is 4, and I keep the original sign. So that's what we're going to graph. So I've got 3, I've got 4. Put them wherever you want. 1, 2, 3, can spread them out. There's no reason why every tick mark can't be 0.25. You can put them close together. It doesn't matter. But I didn't want them too close. It's hard to see. So I'm going to look at the numbers that are greater than 3, which are here. And then I'm going to look at the numbers that are less than or equal to 4, which are here. So the double shading overlap is this section. That's where we're going to shade. It's the overlap. So with an and, we want to find the overlapping region. Less than, open circle, or greater than, sorry. Less than or equal to, closed circle, and then our shading is in between. With an and, you can pretty much expect your shading is going to be in between the two values. And you don't have to do that highlighting. I'm just doing it to illustrate what's going on. But I mean, look at the shading. Are those the numbers that are greater than 3? And those numbers are also less than or equal to 4. Now let's read from left to right. I've got a 3, open circle, less than. I've got all my X's, closed circle, which makes less than or equal to 4. And again, that's a fancy way of saying X is any number between 3 and 4, including the 4. Doesn't include the 3. 3 is not a solution. 4 is one of the solutions. And every number in between is a solution. So like 3.1 is a solution to this compound inequality. 3.7 is a solution. 3.99999 is a solution. 4 is a solution. 4.1 is not. So all the solutions have to be greater than 3, and they also have to be less than or equal to 4. Okay, part C. They give it to us like this. But we know that when we have one long statement with two inequality symbols, it's just an and problem. So I'm just going to separate it. My first inequality is x minus 10 is greater than negative 9. Look at the inequality symbol. You see how it's opening on the x minus 10 side? So I like to put my variables on the left. Doesn't mean you have to, but I like to put my variables on the left. So I'm going to put my variables on the left, and my symbol has to open up towards the x minus 10. Just make sure the symbol is facing the same thing. The opening, the mouth, is towards the x minus 10. The pointy side is pointing towards the negative 9. Okay? And this one, I don't have to rearrange because it's already with the variable on the left. So there's my second one. Oh, just separate it. Put the word and in between them. Right here. I solve that by adding 10. I don't have to multiply or divide by anything. So if I add 10, I get x is greater than 1. And if you add 10 over here, you get x is less than 5. Okay. So without me highlighting, open circle on 1, open circle on 5. 1, 2, 3, 4, 5. I'm looking for numbers. Let me draw that circle better. Okay, I am looking for numbers that are greater than 1, and at the same time, they got to be less than 5. That's the numbers in between. Okay, because like I said, the ands are the numbers in between, because we're looking for where the two different solutions overlap or intersect. So 1 is less than all the x's, which is less than 5. Okay. D is another one. It's all written in one long line, but it is two separate problems. It's the 3n plus 5 with a greater than or equal to sign and the negative 4. So I've got 3n plus 5 is greater than or equal to negative 4. I almost wrote positive 4. And my other one is 3n plus 5 is less than 11. Okay, so this is the tricky one. So I take my 3n plus 5. I look at the symbol. It's opening to 3n plus 5. It's still opening towards the 3n plus 5. The whole doesn't matter if it's a greater than or a less than. It really just matters that the correct side is opening towards the same expression. So this symbol is a less than sign, but the important thing is that it's opening towards the 3n plus 5. It still is. So I didn't change the symbol. I just moved the 3n plus 5 to the other side. It's kind of like saying this. 1 is less than 5. If I want to switch the location of the 1 and the 5, I could put the 5 over here and the 1 here, but I still have to open towards the 5. Okay, I can't just change the location unless I flip that sign around. Okay, so let's solve here. I'm going to subtract 5 from both sides. So 3n greater than or equal to, if I subtract 5, I get -1. And now I divide by 3. I did not divide by a negative. I divided by a positive. Yeah. Oh, it is a -4. Thank you. Yeah, it only works if you write the problem down correctly and not change the numbers halfway through the problem. So let's do that. So subtracting 5 from both sides, I'll get -9. Okay, now I'm still not divided by a negative. This number is negative, but I'm going to divide by 3. So when I divide by 3, I still get greater than or equal to -3. Over here, subtract 5 from both sides. So 3n is less than 6. I'm still dividing by a positive number. Divide by 3, and I get n is less than 6. So we got this and in here. I'm looking for all the numbers that are greater than or equal to -3, and at the same time, they are less than 6. So 3, 2, 1, 0, 1, 2, 3, 4, 5, 6. Ooh, I just did it. So less than or equal to -3. I'm going to put a full circle on -3 because of the equals. I'm going to put an open circle on 6 because there is no equals. And I'm looking for the numbers that are greater than -3 and less than 6. It's these ones. Yeah. Yes.
I think you forgot to divide the 6 by 3.
Oh, I did. Look at that. Thank you. So Christian just noticed I said I was going to divide by 3, but I actually did not divide by 3, did I? So this should be a 2. 6 divided by 3 is 2. So let's fix that. So I've got my -3, -2, -1, 0, 1, 2. And again, like I said, we don't usually draw number lines with the little tick marks. So just a number line with numbers in the correct location to the left or to the right, and all the numbers in between. So thank you. Yeah, definitely if you see me make a mistake up here, please let me know, because that doesn't help anybody if I don't fix my mistakes. Okay, so that's the first page of our notes. The second page goes into or, but as I'm thinking about it, I think I just want you guys to focus on and right now. So I'm going to leave it there. So that means I'm going to change the due date on these notes till next week. So you did one page, you'll go back in next week on Monday, and we'll finish this with doing the ors. So just keep this open, don't turn it in yet. I mean, if you want to turn it in and then resubmit it after it's done, you can, but I am going to change the due date on that. So we're going to finish the rest of these up on Monday. So that's step 1. Step 2 is there's Delta Math tonight. but I'm going to go in right now and adjust the delta math so that there's no OR problems. So give me a second to do that, and I will tell you when it's ready, because as I was going through these notes, I was like, you know what? I just want to focus on one thing at a time. So, oh, and I didn't write the solution here on this one. So this is -3 is less than or equal to all the n's, which are less than 2. Okay, so I'm just going to adjust the assignment so that it only gives you and problems. So don't start it yet. Because if you do, you might see an OR problem, and we haven't discussed that yet. I got my pulsating dot going on Delta Math, so might be a minute before I can get in. So the Delta Math assignment will have these compound inequalities on it, and it will also have the ones from yesterday, just the regular inequalities where they're not compound. So they'll have, you know, an arrow going one way or the other. So I'm in the process of adjusting here. So again, I'll let you know when you can. So boom. Okay, so Delta Math is good to go. So you guys can go in there, and like I said, you will see problems like last night's, like we did on the warm-up. And then you will also see compound inequalities dealing with ands only. So you should not see any OR problems. So we'll do the OR problems on Monday. So figure, hey, you got a half hour, you can hopefully finish your Delta Math. Okay, so I'm gonna stop the recording